Hi everyone. Today we are going to be talking about the idea of function notation. So here we go. Go ahead and follow along with your notes. When using function notation, instead of using y to represent the output, you use symbols like f parentheses x or g parentheses x. In this way, f or g is the name of the function. So just like we all have names, functions can have different names. Okay? So when you see f parentheses x, how you say that in mathematical terms is you say the value of the function f evaluated at x. If you see something that says f parentheses 5, this is not multiplication. I know parentheses usually mean multiplication. In this case, they do not. The value of the function f when x equals 5. A different way to also read this, if you see f parentheses x, can also be read as f of x. G parentheses x can also be read as g of x. So for example, if you see something like c parentheses t, you can read it as c of t. Okay, let's go ahead and move on. Just that's a little math language for us today, so we can move forward with these examples. Today we're going to be doing 6 different examples, and these examples, 3 of them are based on equations, and 3 of them are based on graphs. So let's check this out. Here's the first example. It says Horatio is selling t-shirts at a profit. His profit has been described by the following function, where P is profit and T is t-shirts. So now I look at the function, it says P of T equals 10T minus 7. The question asks, or the problem says, evaluate P of 5. So P evaluated at T equals 5. So again, here we don't see an x, but what we can do is we can take this 5 and substitute it in for the t. Okay? So this is what we're going to go ahead and write. P of 5 equals 10, but instead of the t, I'm going to write parentheses 5 minus 7. So now P of 5 equals, in this case, 10 parentheses 5. Yes, we do mean multiplication. Remember, when you see a number, a coefficient right next to a variable, so something like 10t, that is multiplication. So I'll go ahead and multiply 10 by 5. I know that is 50 minus 7. So now P of 5 equals 50 minus 7, which is 43. And that is my answer, because it asked me what was 5 at this point. Okay? So if I looked back at the example, what this is saying is that when Horatio sells 5 t-shirts, he makes $43. That's what I'm saying. Okay? Let's go ahead and erase this so we can look at example 2. So example 2 is just a modified version of this. It says Horatio changed his costs. So we're still talking about this same problem, but he changed his costs. His profit has been described by the following function. So now this one you're going to notice is in graph form. It's the graphical representation of the function. But I go through and I do the same thing. So it says evaluate P of 3. Now again, this is the input. And remember from one of our first lessons, input is kind of like the x, or is the x-axis when we're looking at this. So let's go ahead and find where x equals 3, or where t equals 3. So I'm going to go ahead and do that. 1, 2, 3. I know that's right here. But now I need to find where it intersects the line. So I see the line is above it, and I notice that it's right here. So how I write this is I say P of 3 is equal to 4. So 4 was the value that I got on the line based on where 3 was at the x. Okay, let's go ahead and move forward. Here are the next two examples. It says Kaon is out throwing a football. The height of the ball is described by this function where h is height in feet and t is time in seconds. Okay, so similar idea. So this is h of t equals negative 2t squared plus 10t. In this case, we actually have two places where we have an input. We have t right here, and we have t right here. And I guess you could consider this t as well. So now when it says evaluate h of 3, I'm going to go ahead and replace every t with 3. So here we go. H of 3 equals negative 2, but instead of the t, I'm going to write 3 squared plus 10 multiplied by 3. So literally all I did was I took these spots that had the t and I replaced them with 3. Now I go ahead and solve this out. I only need to worry about the right side of the equation. The left side is just telling me what I'm evaluating. So I follow my order of operations. I'm going to go exponents first. So I'm going to go negative 2, 3 squared, that's 3 times 3. Not 3 times 2, and it becomes 9. Plus, this is 10 multiplied by 3, which is 30. I keep going. H of 3 equals negative 2 multiplied by 9, a negative multiplied by a positive. We should know is a negative, negative 18 plus 30. And finally, h of 3 equals negative 18 plus 30. My positive number is bigger, so I know that my answer will be positive, and I know the difference between those two is 12. So now what this tells me is that when Kaon, after 3 seconds that Kaon lets go of the ball, the height of the ball is 12 feet. That's what this problem is telling me. Okay? Let's move forward. So now example 4 is very similar, but again we have the graph representation. It says Kaon broke his arm. So meaning that he's not going to be able to throw the ball as high. It says the height of the ball is described by this function below. Evaluate h of 4. So again, I want to look at my input, which I know is my x. So I'm going to look at 4, which is right here. And then I'm going to go up so I can find where it's at. Here it is. That's where it intersects the curve of the graph. So I know my y value, or in this case my h value, is 1. So I would say h of 4 is equal to 1. So again, what this is saying is that after 4 seconds, Kaon was able to, the ball was at 1 foot high. Okay? Let's move forward. Here are the final 2 examples. Hopefully this is starting to make some sense. Essentially, you're just substituting the input value. Let's read this. It says, Isley is skateboarding down a ramp. His height over time is described by the function below, where h is height in feet and t is time in seconds. Okay? So now it says h of t equals t squared minus 3t plus 1. Evaluate h of 4. So 4 is my t value. I'm going to replace every single t with that value. I'll say h of 4 equals everything else I write the same. I see my first t, so I'm going to write 4, except it's squared, minus 3 times 4 plus 1. Again, I follow my order of operations. I do my exponents first. 4 squared, that is 4 times 4, not 4 times 2. So 4 times 4 is 16. I multiply these, negative by a positive is negative 12. And I just bring down my plus 1. I keep going, 16 minus 12 gives me 4, plus 1, which is 5. So h of 4 equals 5. Again, what this means is that after 4 seconds, Eiseley is 5 feet high. Okay. Now this says Eiseley made the ramp smaller. This is the next example, so let's go ahead and erase this. This is the graphical representation. It says Eiseley made the ramp smaller. The height of the ramp is described by the function below. So again, I want to evaluate h of 3. So I look at my input, which is my x value. So I start from the middle. I know that this is here. And then I notice that if I was to find this point, that's just 3, 0. So since it's 3, 0, I know that my value of h is 0. So I write h of 3 equals 0. Again, what this means, after 3 seconds, Eiseley's height is 0 feet. Okay. Hope that was good. If you have any questions, please let me know.